we're going to take a look at this question here. We're going to look at these following equations to determine if they are functions or not, and we'll use two reasons to justify. Now, there are some shortcuts to doing stuff like this. One of the shortcuts is determining if something is a linear function. So if something is linear, quadratic, a root function, a circle function, by algebraically looking at it. To graph each of these could take a really long time, especially if we don't have a graphing calculator. So what we can do is go through the process of trying to set things equal to y, and then taking a look at what we end up with when we have something like that. So we're trying to quickly tell by just looking at it algebraically if it's maybe one of these common ones that we know of or something else, because we actually know very quickly that linear is a function, quadratic is a function, a root is not a function, okay, sideways, and a circle would also not be a function. So we take a look here. You could technically move 20 to this side and y -5 to this side, and essentially you end up with y equals some form of x squared. Because this has the exponent of 1 and this y has, exponent of 2 and the y has an exponent of 1, we know this is quadratic, which means that checks out. That is just like we know it. Quadratics, keep in mind, is y is equal to x squared or some version of that. Linear is y equals x. A root is y is equal to the root of x. And a circle is something along the lines of y is equal to, root squared is equal to x squared plus y squared. Now you could set it equal to y, and it would look something like this. Y squared is equal to x squared, r squared minus x squared. And then you could technically simplify by going y is the root of r squared minus x squared. So some version of that would also give you a circle. Okay, so we rearrange the parent function to figure this out. This one here, there is no y. So if there is no y, when we simplify, this actually simplifies to x is equal to, I think, -14. So we got to think about that. What does that look like on the Cartesian plane? Well, if I have Cartesian plane here and this is -14, x is equal to it, it's just a vertical line going through 14. And a vertical line cannot pass the vertical line test. They would actually be one on top of each other. So what that means, if it can't pass a vertical line test, that's not a function. So we have the first one is a function, the next one is not a function. Here we have y to the power of 1 and x to the power of 1. After we rearrange this, we're going to end up with this scenario because we have a y to the power of 1 and an x to the power of 1. This is linear, which is great. That's going to mean this is a function. I realize I skipped c. Same concept as the one above. X equal anything can't be a function. Okay? This one here, y to the power of 1, x to the power of 2. Means it's quadratic, which means yes, it is a function. Now here we go. This one's a little different. There's no x value. So if we were to work this out, we end up with you end up with y squared is equal to -7, which y is the root of -7. So this is an imaginary number. This imaginary number technically can have a value. It's a negative root, which makes it tricky. I don't remember off the top of my head this one, actually. Imaginary numbers be considered functions? I have to look it up. But what I'm going to do is I'm going to jump forward to this one here, because this one actually works out really nicely. Root function, imaginary numbers. I got to think of that one. Y equals -5 is the opposite of what we had with our x value. We have our Cartesian plane. Let's just say it's +5 just because I wrote it wrong here, or I didn't give myself enough space. We have a horizontal line that just runs across. A horizontal line will always pass the vertical line test, so this does check out. This is a function. This one is questionable because it's an imaginary number. I'm not sure if you guys have talked about that. I don't recall off the top of my head if an imaginary value, I guess when you plot it, it still gives you a horizontal line, so I think my intuition says yes, it is. Okay. Finally, we've got to one where we have an x squared and a y squared, and we know that an x squared and a y squared is actually going to give us a circle function. So because it's a circle definitely doesn't pass any vertical line test, so this is not a function. Giving everything else a quick glance, this one is cubic, but cubic ones also pass. They just have this little like chicane in them. They pass vertical line test, so that is great. Circle, linear, 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 quadratic, linear, quadratic, quadratic, linear, quadratic, horizontal. This is a root function, so we have a positive root value. Y is equal to root 1, which actually gives us a value, which is a horizontal line, so that checks out. But we've actually covered all the cases here. Okay, so by going through all of that first list there, we've actually covered all cases. It's just determining what type of function each of these happens to be.